Ready to complete the Community Garden exercise with Elixir's agent module? The agent is your key to managing simple, centralized states safely in Elixir. We'll use it to build the garden plot registry. Let's dive in and write some clean concurrent code. Grab your starter file and follow along. Howdy, I'm Kevin. In these videos, I combine my development experience and AI tools to help present comprehensive exorcism solutions. I've loaded the exercise into VS Code and prompted Copilot to add documentation, but you're free to use the editor and AI of your choice. I'll include segments of NotebookLM videos or quizzes to introduce concepts. Here's how NotebookLM introduces agents.
What exactly is an agent? You can think of it as a dedicated process whose entire job is to hold onto some piece of data. In our case, a list of garden plots. Every other process has to communicate with this one agent to read or change that data. This approach is what prevents conflicts and keeps our information perfectly consistent.
Using the agent is an idiomatic choice in Elixir for managing simple state because it provides process isolation and concurrency safety out of the box. The agent ensures that only one request to modify the garden state, like registering a plot or updating the ID counter, is processed at a time. This single-threaded access eliminates race conditions that plague mutable, shared state in other languages.
Okay, time to get our hands dirty. Let's open the garden by launching our agent process. What we want is a function that gives us back an OK tuple with the process ID.
Starting our Community Garden, we identify that there's a start function on the agent module that will start up our storage. This is the function that's going to return the OK tuple and the process ID. But the first argument is to initialize our state. And so for our garden, what is our state? Well, if we look in the instructions and open the garden's initial state should be an empty collection of plots. If we look ahead a little bit, we can see down here in step 3, when we register a plot, that each plot's going to have a unique ID, and we should increment it and keep a counter in the state. So those are the two pieces of data that we're going to ultimately need to store. So let's go ahead and set ourselves up for those now. So we need the thing that will store a collection of plots and an ID. There are a number of choices we could use. The first two choices here are tuples, which are just unordered elements. And the last one is a map. Tuples here indicate we could either have a list of plots or we could have a map of plots. The map, very similar. I happen to have it with a list. You could, in fact, take this further to be a struct if you wanted to. So for our purposes, though, the simplest thing to do, I think, is to choose the one where we have a tuple with a list for the plots and a counter of 1.
So our garden's open, but it's kind of a black box. We need to see and change what's inside. First up, let's just read the state. We need a function to list all the registrations.
So there's a function on agent for getting the value out of its state, get. You call agent.get. You give it the process's ID, and then you write a function that, given the state that that agent is holding on to, it returns some value. So in our case, what we're looking for is the list of plots, and we gave our state as a tuple where the first element is the plots and the second is the plot ID counter. So what we're going to do here is we're going to pattern match plots and the next plot ID and return the plots. If you had chosen a map or some other data structure up here, you would need to pattern match or perform the corresponding operation down here.
This is where things get really interesting. The challenge isn't just adding a name to a list. We have to assign a unique incremental ID to every new plot. And we have to perform this update atomically, meaning the entire operation has to happen as one single indivisible step. The key function here is agent.update. Unlike get, update is for changing the state. We give it a function that takes the current state and returns the new state. Elixir guarantees this function runs without any interruption, which prevents any other process from messing with the data while we calculate the new ID and add the plot.
Registering is perhaps the most involved of the steps in this exercise. We're supposed to take a person's name who a plot's going to be registered to. We need to create a new plot. We need to update our state, and we need to return that plot. So when you look at the agent functions, there's one that might seem all right, which is just plain update. But update only updates the state. It doesn't return any other piece of data. Get would be fine, except for that it doesn't update the state. And you want to do both at one time so that nothing else can get in between these two operations. And so conveniently, there's one that's get and update. All of these agent functions will take an argument, which is the function, which is its current state, and then do some work. So we are going to use get and update. The function is going to pattern match state to be our tuple of plots and next plot ID. So we need to first create a new plot with that next plot ID and registered to the person passed in. Then our new plots is we're going to prepend the plot we just created onto the existing collection of plots that we have. Then we're going to create a new state given the new plots and increment the plot ID. This is a case here, for example, where you would almost assuredly inline that. And then our return is both the value the call to get would have, the thing we want to return, and the new state that the agent should hold on to. And that happens to also be a tuple. So we're returning the plot we created and the new state. If you had chosen to store your state in a map, you would have to pattern match differently up here. And if you had chosen to store your plots in something like a map, you would then do a different operation here when we're updating our plots and our state.
Did you know that because the agent is built on top of the beam, it can survive critical failures? A supervisor process can be configured to monitor your Community Garden agent. If the agent process crashes due to an unforeseen error, the supervisor can automatically restart it, often restoring the last known good state, a concept known as let it crash, providing fault tolerance that is nearly impossible to achieve in traditional imperative environments.
We're using agent update again, and this shows its versatility. Update is for any kind of state transformation, not just adding things. This time, the function we provide filters the list, creating a brand new state that simply excludes the plot with the ID we want to remove.
Releasing a plot simply wants us to return OK when we've done it. So all we need to do is update our state. We don't need the get and update function we used before, just update. Again, we have a function which takes the state as an argument. We're going to pattern match that to our tuple, the first argument being our list of plots. The only reason we care about the next plot ID is that we need to return the updated state, and so we need to pass that along unchanged. This is where my choice of using a list for the plots could be a performance problem. Here we're saying take the list of plots and reject out the one with the matching plot ID. This could cause a fairly expensive recreation of a list of plots. This is a case where maps would be better. Nevertheless, our plots are a list, so we're going to reject out the one with the matching plot ID. That gives us a new list of plots, and what we return is a state, our new state, and we're storing our state as a tuple with the plots as the first argument and our plot counter as the second.
Our final task involves a specific query. We need to find one plot by its ID. But, and this is important, we also have to gracefully handle the case where that plot doesn't even exist. A robust API always gives clear feedback for both success and failure. For this, we go back to agent.get. We give it a function that searches the list of plots for a matching ID. If it finds one, it returns the plot struct. If it doesn't, it returns a descriptive tuple, something like 0 not found, plot is unregistered. This provides a clean, unambiguous result to whoever called it.
For get registration, we're given a plot ID and we need to find it in our collection of plots. So we'll use the agent.get function that's going to return a value from our state. We're going to pattern match the existing state with our tuple of plots. We don't care about the next plot ID for this operation. So given our plots, which is a list of plots, we're going to use enum find. We're going to look in that collection of plots. Now, enum find, the second argument is the default value. That is, if it's not found, what do we return? And the instructions have us returning a not found tag tuple. And the function to find the plot is find the thing with the matching plot ID. Also a case, as we'll see in a moment, where a map would be better.
The core lesson is this. Agents protect state by locking it inside a single process. All requests, whether a read with agent.get or a write with agent.update, are just messages sent to that process. It handles them one at a time in the order they arrive. This single file line for all state changes is exactly how it prevents race conditions. And by wrapping these calls in our Community Garde module, we've built a clean, safe, and easy-to-use API.
Let's take a look at what it would be like if we had chosen to store the plots as a map where the plot ID was the key and the plot was the value instead of a list. Here, when we start our agent, we would give it an empty map instead of an empty list. When we want to list the registrations, we still call get, we still pattern match the state as a tuple of plots and the next plot ID. It's just that plots is now a map. And if you remember, the plot ID was the key and the plots were the values, so we call map.values. When we get down to registering, we still pattern match our state. Plots is a map now. So when we create our new plot, we put that in the map with the plot ID. And then we still update our state with this new map. Here, lists are still winning from a performance perspective because prepending to a list is incredibly efficient. Here's where the tables turn. When we release a plot, we still pattern match. This is plots is now a map. We call map.delete with that plot ID. And we update our state. This is where maps take over in terms of performance. And when we want to get a registration, we have our map of plots. We can call map.get with that plot ID. Similar to enum find, it's just now the last argument is the default, where if we don't find it, this is what we want returned. This is also more performant than walking the list. Let's take a look at an example of benchmarking. I've run Benchy here, and we can see here that the list is a little bit more than twice as slow and would be particularly worse as the number of plots were to increase. If it's a very small number of plots, then either of these implementations would be just fine. We've successfully planted the seeds of agent knowledge today. If you want to help this channel grow in the best Elixir content, be sure to hit that like button. Make sure you secure your plot in this learning community by hitting the subscribe button. Dive into the playlist to build your Elixir expertise one powerful function at a time. See you there.